All right, so we have introduced the idea of hypotheses and p-values. We'll get into formal statistical decisions. If we look at this example, innocent until proven guilty, very commonly used example in explaining a formal statistical decision and what the null hypothesis and alternative hypothesis means and what it means to reject and to fail to reject. If we say that someone is innocent until proven guilty, that means the null hypothesis is that the person is innocent. The alternative hypothesis is guilty or not innocent. So we want to think about rejecting the null hypothesis as being the idea that the null hypothesis is that the person is innocent. If we reject that, that means we are finding them guilty. So to reject the null hypothesis means to find guilty. If we fail to reject the null hypothesis, this means that we do not find the person guilty, but keep in mind this does not mean that we have proven the person innocent. We don't prove innocence in a court of law. The only two things we can do are find guilty or fail to have enough evidence to convict, right? A person might well be guilty and be released, and that person would not be in their right to turn around and say, I have been proven innocent. So we do the same thing in statistics. We never ever prove this null hypothesis to be true. We might fail to gather any evidence that it's false, but we don't ever conclude from that it's true. We either get evidence against it or we fail to get evidence against it. Now, since this is just like a sort of a yes-no question at this point, right? Either we reject or we fail to reject, we need some criteria. And the criteria we usually use are significance levels. We use this Greek letter alpha. Looks a little bit like you're trying to draw an infinity but not quite closing the second loop, right? Looks like this. This is a predetermined level at which we make a decision, a statistical decision. So for example, in our draft lottery question, our p-value was equal to 0.01. If our statistical significance level is 0.05, we see that this is less than 0.05. That's the predetermined significance level. So at the 0.05 level, we would reject the null hypothesis. That means we have evidence that the alternative hypothesis may be true, and therefore we are rejecting the null hypothesis, which is something contradictory to our alternative hypothesis. Now, if we're not given a specific significance level and we're asked to conduct a test of hypothesis, we can just describe the strength of our evidence. So the most commonly used significance levels are 0.01, 0.05, and 0.1, and we can use these to break apart a number line and designate these categories: very strong, strong, moderate, weak, weak, none. I would say the none category is over here. Anything that's above 0.15 is considered no evidence. We wouldn't even call it weak evidence at that point. This is something that just by luck we would see 15% of the time. That's not evidence of anything. But we can describe the strength of our evidence using this scale, and usually we do that if we're not given a significance level. So for example, in our draft lottery example, we had a p-value of 0.01. It usually doesn't come out to be exactly equal to one of these, right? But we didn't have very many dots to count. So that was about our p-value. Usually you find that it's between two of these. So the p-value from the draft lottery example was right here in very strong to overwhelming versus strong territory. I might just go ahead and call this strong evidence. Whether you call this strong or very strong doesn't really matter, right? We're in the ballpark. We would say strong evidence in this case. And generally we want to write up a really nice conclusion using non-technical language so that it's clear what you're concluding. When we reject the null hypothesis, what does that mean we have found evidence of? If we have strong evidence, what do we have strong evidence of? So we get into this stating conclusions topic. So sometimes we have a significance level that is given. I'll call that case 1. If your significance level is given, it makes sense to reject or fail to reject and have that be your conclusion. We have statistically significant evidence that, we do not have statistically significant evidence that, and then we would describe in words what our alternative hypothesis is. So here we would describe this in words. And it often makes sense if you had a verbal description of your alternative hypothesis to begin with, you could just fill it in here. If you have only a symbolic version of it, then you'll have to translate that to words. If we have no significance level given, then we want to describe the strength of our evidence here. Pick a word. So in our draft lottery example, we said strong evidence. We would write in strong. And the alternative hypothesis is true. That is that the mixing method favors December birthdays. When we write this using non-technical language, it's very important that it's clear what we have found evidence of or what we have failed to find evidence of. So we have to say everything in the context of the problem in such a way that would make sense to somebody who has never taken a statistics course, right? We have strong evidence that the mixing method favors December birthdays. If we've been given some background about what we're talking about, that makes perfect sense. Now, if we want to state the conclusion from the draft lottery question at the alpha equals 0.05 level, that's looking at the case 1. So this is what we're going to write down here. At the alpha equals 0.05 level, that's where we are given a statistical significance level alpha. So we want to think, is that reject or fail to reject? We already determined that this is reject, right? Reject H naught. So we can come down here and try to write following this model. We have statistically significant evidence at the alpha equals 0.05 level if we want to, that, and then we just have to describe that HA is true. So I wrote this as we have statistically significant evidence. We could say at the 0.05 level, that's not a required part of our conclusion, because we're told the significance level, that the mixing method favors December birthdays. Anytime that you are asked to state a conclusion using non-technical language, which you will be asked to do over and over again, you want to come back to this stating conclusions area in your notes right here and follow one of these models. depending on whether you were or were not given a significance level, and depending on whether you reject or fail to reject, if that is the case.